In this video, we are going to understand another implementation of linear optimization in, for example, inventory control or production planning. So in this case, we are going to give an example of a home-based company. Okay, it's called Kristen's Creations, that makes hand-painted jewelry boxes for teenage girls. Forecasts of sales for the next year are 150 in the autumn and 400 in winter and 50 in the spring. So these are the forecasts. These are the values that they should produce. Plain jewelry boxes are purchased from supplier for $20. The holding cost per item is $1.20 per quarter per 3 months. Kristen hires art students part-time to craft her design during the autumn, and they earn $5.50 per hour. It's per hour. Labor rates are higher in the winter, and the workers earn $7 per hour. In spring, workers earn $6.25 per hour. Here is the quick fact: each jewelry box takes 2 hours to complete. So remember, these values are per hour. Okay. How should production be planned over the 3 quarters to minimize the combined production and inventory holding costs? Okay, we'd like to minimize the total cost. Which costs? Those are the inventory holding cost and the combined production cost. Again, even though this is a simple case study, this problem can be found in any service company or any manufacturing company, right? So basically, how are you going to allocate your workforce in such a way that you produce what your forecast says, in such a way that you have the minimum production and inventory holding cost? Okay, again, the first stage here is to define the right decision variables. So what are the decision variables? What are the things that we can control? So if you take a look at this problem one more time more closely, so you do have 3 quarters, and then you do plan for each quarter. And what you are basically trying to decide here is that, how much to produce in each quarter, right? And then you do have the option to keep them in inventory. And how much to keep them in inventory, we don't know. And then you can let this model to handle that for you. So the other decisions that you would be interested in making is that, how much to keep in the inventory at the end of each season. Well, you do have 3 quarters, right? And then you do have a production decision variable for each quarter, and then you do have an inventory decision variable for each quarter as well. So P's are going to represent the production values for each season, for each quarter, and then I's are going to be the total amount kept at the end of autumn, IA, IW at the end of winter, and IS is at the end of spring. Okay, so basically you do have 6 decision variables for this problem. Okay, by using these decision variables, let's see whether we can put together this objective function. Again, the objective functions are going to be the labor costs, right? And also inventory cost. So before that, what this graph tells us, these are called the inventory balance flows. So what's coming in here for the quarter of autumn is the production amount, right? So we produce, it's coming into our system. 150 is the forecast we have to satisfy, so it's going to be shipped to customer. And then there might be some products coming out for winter, to be held in the inventory for winter, right? And for winter, we might be having something from the previous quarter, IA, and we would be adding something into system by producing PW amount. And what's coming out here is that 400 units of forecast, we are going to ship this to customers, hopefully. Okay, and then we are keeping some unit at the end of winter to be stored to cover the demand values that we get from spring. We have to do the same thing for spring. Again, we do have the production amount in spring. Coming out is the demand, and then also the inventory that we keep at the end of spring. So if you represent your constraints, these are called flow of balance constraint. Okay, and what this does is it basically checks this, right? So what's coming in needs to be equal to what's coming out. So for example, for the first quarter, what's coming in is only PA, and what's coming out is 150 plus IA. And for winter, this is for right, for winter, what's coming in here is that IA plus PW, 400 plus IW, and for spring, that is IW plus PS is equal to 50 plus IS. The only reason I jumped to the constraints before explaining the objective function is because there is this flow of inventory balance flows here. I wanted to explain them, but what you can see here is that this constraint is actually in this first constraint, and these constraints are arranged in such a way that these constraints have the constants on the right hand sides. Okay, it's just rearranging these constraints that I wrote here, you will get these three constraints at the same time. Okay, so what these flow balance constraints do, they do the right communication between each consecutive quarters, right? What's coming in needs to be equal to what's coming out, and those are really your constraints, right? Other than your non-negative restriction. So let's go back to the question, and then let's go back to see whether we formulated this objective function values correctly. So in the first quarter, the students require $5.5, right, per hour, I guess? Yes. And then each box requires 2 hours of completion time. So you just need to multiply this by 2 to get the per box how much labor that they require, and then you have to do this for all these cost values in order to get correct cost value for each quarter, right? And then if you'd like to keep something in inventory, it doesn't matter which quarter you are in, you have to pay $1.20. Okay, and this objective function here, the first portion, this portion is the manufacturing cost or the production cost, and this portion right here is our inventory cost. Sometimes it is more beneficial to, for example, produce goods here and then use them here and here, right? Inventory cost is not that high, but we don't know what the optimal solution is, so we are going to use Excel solver for optimally solving this problem. Okay. Here, for each quarter, I reserve these cells as my decision variables, and then you do have the production inventory costs for each quarter. You do have the demand values for them. All we have to do is to represent the net production. Net production, those are the values that you see here, right there. For example, for the first one, it's just PA minus IA. So these are the P values, and these are the I values. This net production says PA minus IA. For the second quarter, what we have here is that PW plus IA minus IV. So here it is C9. C9 is PW. PW minus C10. C10 is our I2, right, going out, plus B10. B10 is our inventory going from autumn to winter, right? Okay, that's correct. And then this third one is exactly what you see here in this left-hand side. The only reason that this is written that way because solver likes a constant right-hand side, or you could have written these constraints like this as well. Right, so what we are going to do is go to solver, set up our objective function. Okay, our objective function, let me show it to you, is just the sum product of these with the production and inventory costs, because this line or this row is going to hold how much to produce, and then this one is how much to keep in inventory, right? and this is exactly what you have. This is the first row is going to be the production cost, and then the second row is the inventory cost. So you can subproduct them together to get the total cost. Okay, so the solver minimization of this total cost by changing these variables right there, and then the constraints are basically the net production. Let's do it together. I have 3 constraints. I can, since they have the same symbol equal to, I can select them together and add it to the objective function. So this box is checked. It makes sure that the production and inventory constraints are not really negative. They are all non-negative, right? And then here click solve. There you go. Solver found the solution. All constraints and optimal conditions are satisfied. According to this graph, so I produce my first quarter, and then I don't produce anything in the second quarter. I think this because labor cost is really expensive, $14, right? And then I use whatever I produced in quarter one for quarter one and for quarter two, and then again I produce the demand value for the spring in quarter three, and then don't keep anything in inventory. The total cost for this production plan is $7,155. That's pretty neat.